Welcome to our first abstract data type for ICS 211. We're going to be talking about the list abstract data type. So what is a list? It is just a collection of items that have a order to them. So example, the first thing on your list, the second thing on the list, the third thing on the list. Lists are different from arrays, which have the order to them, whereas lists can grow or shrink depending on if you add an item to a list or remove an item from a list. That shrinks the list, and lists do not have gaps in them. You have a first thing, a second thing, a third thing, and a fourth thing. You cannot have a gap in your list. Whereas in an array, you can have a gap in the array by setting its value to null. Also, arrays cannot be resized once they're constructed. You have to create a new array and copy the contents out of the array into the new array if you want a larger array. So what is the Java list abstract data type? Well, here's an example of the Java interface. Notice that it has the less than e greater than here. You may be wondering what that means. A list has a specific type to it. A list can hold specific kinds of things. The Java notation of using the E here is saying that when we create a list, we will describe its type when we create it. For example, the list string named strings holds only strings. You can only put strings into this list. You cannot put in doubles or books or anything else. Same thing, if you want a list of integers, you say list and then put the type or the class name of the object you're interested in, and then the name of the variable. So you could have a list of strings, a list of integers, a list of books, a list of objects, a list of whatever Java class you have. So let's take a look at what you can do to a list and its abstract data type and its interface. So you can see that the list extends a collection, so is a collection. Collections provide some interesting operations, which we'll talk about later in another lecture or another screencast. So you can get an item in the list at a given index, and it returns the item, which type will be set when you create the new list. You could set the item at an index to a new element, so that changes the value of the item at the list at index to the new element, and the old element is returned so you know what was there. You could search the list to say, where is this object in my list, and it will return the index of that item, or -1 if the item's not found in the list. You can remove an item from the list, which would then shrink the list and have no gap. So you remove the item at index and it will return the item that was there. That item is no longer in the list. You can say how big your list is. You can return the size. And so if you want to add to the end of the list, you call add and you give the element that you want to add. It returns a Boolean whether or not it's successful in the add. And you can add to the middle of the list or any place in the list by saying I want to add at the index this element, and that will shift all the elements from index on basically to the right, so they will have one larger index. So something, if you're going to set insert into index 2, the old item at 2 is now going to have an index of 3 and shift everything down the line. So you can add to the middle of a list or anywhere in the list using the add index an element command. So there are many different possible ways to implement the list interface. The first one that we're going to discuss is the ArrayList, which is a resizable array implementation of the list interface. So we are going to use an array to hold the objects that we're storing in the list. So this is going to be slightly confusing because we're going to use an array to implement a list. It can be a little confusing, so we're going to store the objects in the array. One of the great things about this particular implementation of ArrayList, it is very easy to to get and set the items in the array, in the list, because the index in the list is just their index in the array. One of the negatives to the ArrayList implementation is that if the list size gets to be the same as the array size, we need to grow or create a new array that's larger and copy the values in the list to this new larger array, and that's an expensive operation because we need to create a new one and we have to copy everything that's in the list. This can be a time-consuming operation. The array that stores the items has to basically always be larger than the list, so we have a bunch of empty space at the end of the array. This is wasting some memory, and that is not totally wonderful. If you can have a list that just uses enough, that would be more efficient, but if your array is always the size of the list, you keep having to allocate a new array and copying the values, and that is a very expensive operation. And if you insert something into the middle of the array, you have to shift the values out of the way before you do the insertion, so that's a copying of the elements first, and that's again a potentially expensive operation. You'll see a little bit later. We have a for loop that does the shifting. So, what does the implementation look like? So here is our beginning of our implementation. We have our class ArrayList, given the generic type E, extends abstract list, which is a Java class that implements the list interface, but we will override all these methods to make it correct for our array implementation. We set up a private static final int that is your initial capacity for the array. How big are we going to make the array when we construct an empty list? We have something, and so instead of using magic numbers, we declare the variable. We have our data array, which is what will hold the data in our list, and we have to keep track of the size, because the size of the array is not the size of our list. So how do we construct one? We set the data to a new object array of initial capacity that we cast to the type of E. Now in Java, we cannot instantiate a generic object E or a generic type E array. It's a quirk of the Java language, so we just have to create a object array and then cast it to the right type when we know the type when we construct this array list. So in the couple slides before, we had an array of our list of strings. The type E would be string, so we would know what the E is when we're creating this array list with strings. We also set the size to 0 because this is an empty list, even though our data array has a size of initial capacity, which is 10. So again, the size of the list is different than the size or the length of the array. So how do we add something to the end of the list? So here is our data array down here, and it's currently got a size of whatever the current size is. We have to check to see if the size is the length of the data, the array. If it is, we have no more room in our array to store the new entry, so we need to reallocate, and the reallocate method I'll talk about later on doubles the size of the data array and copies all the old values of the data array into the new data array and assigns it. So what we do, we just simply set the entry in the size, and then we increment the size, and then we always return true. And because it's an array and it's 0 based, this size is going to be 1 larger than, the entry goes into the end, which is the size. So how do we add to someplace inside the list, not at the end? So first off, we take a look at the index and the entry. We say, oh, is the index not within bounds of our list? If you tried to add negative indexes or beyond the end of the list, that is not correct, so we throw an array index out of bounds exception, indicating that the index that the user used is not within the list. Again, we check to see the size of the list compared to the length of the array. If they're the same, we make the array larger so that we can actually insert this new item into the list. And then we have to start shifting the things at the end of the list over one, because we need to create a space here for the new entry. So we loop through, and now this is empty. So now we can insert the entry in there, and now we increment the size. And we are done. Notice we don't have to return anything. The set and get methods, very, very simple. Again, we always want to check if we have an index, we want to make sure that the index is within the bounds. If it's not, throw in an array index out of bounds exception, and we simply return the thing in the array at the given index. To set it, same idea, we check its index, make sure it's in bounds. We get the old value, because we want to return the old value. We then set the entry at the place to the new value, and we return the old value. Very simple. To remove, we want to get rid of the thing here, and we have to not have a gap in our array. So again, first thing we do, if we have an index, we always check to see that the index is there. We then restore the data that's going to be returned, and then we start shifting the values over, and then we decrement size, and then we just return the old value. So now this thing is gone and returned, and everything's been shifted down, and the size is shrunk. And again, this is now empty. And the reallocate method, the last one that I talked about, just simply calculates, doubles the size of the current data array, and then uses the array's copy to create a new array that is a copy of the old array with a larger capacity, so twice the size. We use twice the size to hopefully keep ahead of the additions. So as the array gets larger, we're allocating more and more space so that hopefully after a certain point we won't have to do this very often. And thank you for listening to the initial discussion of the list abstract data type.